we begin, here is a short disclaimer about the animation. So, due to both solutions being aqueous solutions, there are bound to be lots of water molecules present throughout.
There are actually two things to take note over here, the copper anode as well as the high concentration of chloride ions present in the concentrated solution. So now let's zoom into this particular solution. Because the anode is made of copper, the Cu atoms inside the anode will actually be oxidized to form Cu2 plus ions. So why isn't anything else reacting with the anode? That's because of the redox table. And as you can see, when Cu atoms become Cu2 plus ions, there are actually two extra electrons, the two yellow things on top, that are produced when Cu is oxidized. So when more Cu is oxidized, A would actually decrease in size, and with lesser Cu atoms to actually hold together the whole structure of the anode, therefore the impurities will start falling out. So let's take a macro view at what's happening over here. So as you can see, the electrons are slowly traveling from the anode to the cathode, and as you watch the electrons flow over, take a brief moment to consider the discrepancy between the loss in mass from cathode A and the gain in mass from cathode B. So the discrepancy is actually going to be how much the mass of the impurities that were present. As we watch the electrons slowly move over from the anode to the cathode, so 2 electrons for every Cu that is oxidized, let us briefly consider the changes in concentration, or like the changes in electrolyte color, which in this case would be none, because the Cu from like the anode will actually oxidize to become Cu2 plus, which would then be reduced and replenish the concentration of ions that is present in the electrolyte. So now the electrons are moving towards cathode D, and let's consider what is exactly going to be present at cathode D, which is going to be its My plus ions as well as the H2O. So keeping to the mole ratio of the charges that we've calculated beforehand, Cu2 plus as well as M3 plus, as you can see, there are a total of 6 electrons entering the cathode. And at the cathode, you would expect to see M3 plus ions there as well as H2O. Now let's zoom in and see what will happen at the cathode. So as you can see, there are 6 electrons, and going by our stoichiometry, there should be actually 2 M3 plus ions that would be oxidized to form M atoms based on the 6 electrons that are present. Here the reduction of M is taking place from plus 3 in M3 plus to 0 in M. And as you can see, all the Cl minus ions are attracted towards the anode side. So going by the stoichiometry that have already been conducted, we've actually found out that the number of Cu atoms being oxidized is the same as the number of Cl2 gas that would be produced. So as you can see over here, each Cl would oxidize to form 1 electron and combine with another Cl to form Cl2, and there will be a total of 3 Cl2 molecules, thus forming a total of 6 electrons. And of course, another assumption that we have made over here is the assumption that all the gas would be captured, as well as all the Cl minus ions that are present inside the water, inside the solution, would always be oxidized, thus the very nice balance of 1:1. So now we zoom out to see the electrons traveling from the electrode C to electrode B, and as you can see, there is a layer of M solid outside of the M cathode, as well as, it's not illustrated here, but there would have been a decrease in this mass of A, as well as accumulation of impurities underneath, because most of the Cu has been gone, and therefore there's no structure holding the impurities and Cu together. So now that the electrons have moved towards the cathode B, let's zoom in to address what will happen in cathode B. The 2 species present at cathode B would be Cu2 plus atoms as well as H2O molecules. So as you can see, there are a total of 6 electrons that have been transferred from Cl minus to cathode B. Each Cu2 plus ion will be reacting with 2 electrons to produce Cu solid, which would code onto cathode B.
So now it's time for us to address the stoichiometry. So first of all, we found the number of moles of copper that was reduced by taking the mass of copper gained by cathode B divided by the molar mass of copper. So on the other hand, we also managed to find the number of moles of M that was reduced by taking the gain in mass by cathode D divided by the molar mass of M, which was given. So following that, we were actually managed to find the number of moles of electrons that will be produced by the oxidation of Cu to Cu2+, and from there we also managed, so afterwards we decided to compare My+, Y meaning the charge of M, which we divided by the ratio of electrons present to find out that it rounded off to 3, there was the nearest integer. So that's how we got our stoichiometry.
That's the end of our performance task. Hope you have enjoyed and thank you.